Hi everyone, welcome back to Mind Over Math. In this video we're going to be covering the introduction to logarithms. Two ran over and told 100 what had happened, and 100 came to see what was going on. So if you can remember this little illustration, log base 10 of 100 equals 2 was or did look like 10 squared equals 100. That'll help you keep the movement of the numbers a little clearer. So here are some of the properties of logarithms that we're going to be dealing with. The definition, which is what I just said. Here is one called the equality theorem. Log base b of x equals log base b of y. Therefore, x equals y. Now we're going to illustrate every one of these probably 10 times in the entire logarithm series. This one is called base change formula. Base change formula says if I don't have this in base 10, which is log, and I don't have this in base e, which is natural log, I can rewrite it as base 10 by putting this base on a log underneath. Second choice is I can actually put natural log of x divided by natural log of b. Now we're going to be using these and looking these up, but these are the rules. Here's another rule, kind of the inverse rule. And it says b to the log, now all of that log base b of a is up in the exponent, equals a. Now I've color-coded it so you can kind of see this. And again, we're going to work these out. This next one is called the product rule. And this one's called the division rule. And this one is called the power rule. So the first one up here is definition. The second one is the equality rule. The third one is the base change rule. The fourth one is the base equality rule. The fifth one is the product rule. And in exponents, we would recognize it this way. B to the u times b to the v is b to the u plus v. This is the quotient rule, where you subtract the exponents. And the last one is the power rule. We've done the power rule in exponential. Okay, so let's illustrate that. Log base b of 1 is 0. When you write it as an exponential, b to the 0 equals 1. Now this is a good exercise for you to try to duplicate. Let's put numbers there. Log base b of 1 is 0. Let's try that. 4 to the 0. Hey, anything to the 0 power is what? 1. So this is actually a very simple, your most basic logarithm rule. You know this one. You know log b, you know b to the 0 equals 1. Anything to the 0 power equals 1. Next rule, log base b of b is 1. Now with color coding here, I can rewrite this as I did. And you will see if I use a 3, log base 3 of 3 equals 1. Well, what would that look like as an exponential? Well, it would look like 3 to the 1 equals 3. Now look over here to color and see if you follow how the same statement can be written. They are the same statement, just like a fraction can be turned into a decimal and a decimal into a fraction. Next, we have the exponent rules with an example. Log base 5 of 625 could be rewritten log base 5 of 5 to the 4th power. Now, you may not be too familiar with this, but 5 to the 4th power is 625. So look what the answer is. It's this 4. So look up here at the rule, log base b of a is a. And look down here. Now I rewrote this as an exponential in case it doesn't look very good to you. Okay, the same base formula says if I have a logarithm that has the same base, I can find the solution. It's pretty easy. Base change formula says if I'm not in base 10, which is called common log, log, I can get to base 10 using the base change formula. So I went from base b to base 10. There's another version of it called natural log. Natural log base e of x equals natural log of b. In a minute, we're going to work one of these out, and you're going to see it comes out just to be the same answer. You see, your calculator has base 10 and base e. It doesn't have base 2, as in this problem. So to work this with a calculator, we really wouldn't know how to do it without a calculator. You would have to do log, can you follow this? Log base 10, that's on your calculator, of 15, divided by log base 10 of 2. So on your calculator, you'd hit log of 15 divided by log of 2. Here's what you'll get, 3.907. You could also do this with natural log, that other button on your calculator. You could do natural log of 15 divided by natural log of 2, and you would get 3.907. Let's do another one, though. Log base 4 of 29 equals log base 10 of 29 over log base 10 of 4. Notice how this base became, it's a base 4, a denominator, and it is on a log base 10. You see, we can put these into a common log, in common, base 10. Then I can use my calculator. Here's the answer I'll get, 3.0404. Could I do this in natural log? Yes, I could. Now this base change formula allows me to do it either way. You can't do that every time. You can't just use natural log button with base 10 button. No, you can't. In this one case, base change formula, you can do that. So what's this mean? Well, let's go back up here. If I had 2 to the 3.907 power, you could do that on your calculator, 2 to the 3.907, remember a logarithm is an exponent, you will get, guess what, 15. Same here. If you want to check this, just try base 4 to the 3.0407 power, and guess what you'll get, 29. In the upper right-hand corner, make sure you subscribe. In the upper left-hand corner, make sure you check out other videos. Likes are below, and make comments on topics you need.